Hey everyone, we're asked to find the variance and the standard deviation of the following sample data. There's only 5 data values here, so it's not a big data set, but I want to show you how to find the variance and the standard deviation using the formulas. Now the formula for variance and standard deviation, I'll show you right here. For the variance, the formula is S squared is the notation that we use. The sum of x minus x bar squared all divided by n minus 1. And if this were a population data set instead of a sample, we would just be dividing by n instead of n minus 1. That's the only difference between the variance for a sample and the variance for a population. But you'll notice we have to do x minus x bar. X bar is the mean. So we obviously will need the mean of this sample data. So we can calculate the mean by adding up all of the data values, the summation of all the data values, divided by however many data values there are, and we said there's 5. Well, when we add up these numbers and divide by 5, we get a mean of 0.146. I'm going to round everything to 3 decimal places here. So this is the x bar that we're going to use in the formula for variance. Now this formula is a little complicated, so it's helpful to create a table so that we can do a little bit of this formula at a time. And here's what I mean. Here are the data values, the x values. The first thing we're going to do is do x minus x bar. We're going to do that for every one of these data values. So that means we're going to take 0.11 and then subtract the sample mean, which we said was 0.146. And when we do that, we get, for the first one, we get 0.036, but it's a negative 0.036. And we do that for this guy, 0.06 minus 0.146. And that one turns out to be a negative 0.086. Now, these are the values I'm interested in, right? Those are the x minus x bar values. Then we do this one, 0.19 minus 0.146, and that one's 0.044, and so on. Now these are what we call the deviations. This tells us how far each one of these data values deviates from the mean, from the x bar. Now, what we're doing when we're finding variance is we're trying to figure out, on average, what are the deviations? On average, how far away is each one of these data values from the mean? Well, to calculate an average, what we normally do is we add up the data values and divide by however many there are. But when we add up these data values, we're going to discover that the sum of these, if we did this, if we summed all these up, we would find that it's 0, because some are negative and some are positive. Some of these data values are smaller than the mean, some of them are bigger than the mean. So to get around that, what we do, and that's why we have the x minus x bar squared in the formula. So what we're going to do is we're going to take each one of these data values, or rather each one of these deviations. We're going to take each one of these deviations and we're going to square it. So we're going to take negative 0.036 and we're going to square it. Now I put it in parentheses. If you do this in the calculator, be sure you put it in parentheses, because it's the negative that's being squared, not just the number, but negative 0.036. Now when you square that one, you get 0.001. And then we do this all down the line here. We take negative 0.086 and square it, and that one's 0.007. And then we take this one, 0.044, and square it, 0.002, and so on down the line. I'm going to average those. I couldn't average the deviations because the sum was 0, but we can add these up. So the sum of x minus x bar adds up to 0.055. So that's what you get when you add up all these square deviations. Now what we have, if you look back at the formula, we've just calculated the numerator of this formula, x minus x bar squared, and then we summed all of those up. So if we take, let me rewrite the formula down here. Well, we just said that the numerator of that formula is 0.055. N minus 1, well, remember there were 5 data values. 1, 2, 3, 4, 5. So n minus 1 would be 4. So 0.055 divided by 4 comes out to be 0.014. 0.014. Now remember, this is the variance. This is the variance for the sample. And we use that notation s squared so we don't forget the fact that we got that number by squaring these deviations. Remember, we want standard deviation, which is not s squared, but s. Well, if you've got s squared and you want s, well, just take the square root of s squared. So that means we're going to take the square root of 0.014, and the square root of 0.014 is equal to 0.118. So this would be the standard deviation of the data set, and here was the variance of the data set.